All right, you get me again. Yay. So we talked about an ideal situation in Oakville, Tokelon, North Coast area. Now I'm going to talk about some realities that we're facing with as far as mechanization is concerned, because labor is at a premium right now. So we have some driving factors that is requiring us to mechanize some of the operations in the vineyards. We talked about harvesting yesterday, but 90% of the acreage is already mechanically harvested, so I'm not going to talk about that within this talk. So number one thing is timeliness of cultural practices. Mean vineyard sizes are approaching 260 acres in California. It's not possible to get through these vineyards, with migrant labor force as much as we would like to. And there's also a lack of a willing labor force. People do not want to work in vineyards. I grew up on a raisin ranch. I certainly did not want to work in a vineyard. I mean, my job was to, follow people cutting grapes and, putting them into trays, make sure, they got everything off the vine. I certainly didn't want to do that. And of course, the cost of labor is increasing. And then there's also quality of life and socioeconomic factors that is driving mechanization. We are a rural industry. We are not close to our population centers where we can, bus people in to, do work in vineyards. And there's also land availability and cost. There's foreign competition. Land is cheaper elsewhere. Water is more available elsewhere. So therefore, we're evolving towards the spatio-temporal management of vineyards. Presently, we are doing a lot of uniform vineyard and soil management, which involves bulk or composite vine and soil sampling. More advanced of us are doing this interim approach, which is zonal vineyard and soil management, which involves stratified random sampling within a zone. Future approach will involve much more site-specific management, which is fine grid sampling or sensing or scanning using either satellite or in-ground sensors. We can do everything by machine in the vineyards. It depends on how pretty you want the vineyard to look. We can do dormant pruning, suckering, shoot thinning, leaf removal, berry or cluster thinning. And we can certainly do a harvest. So when I divide the commodities, wine, raisin, table grape, harvesting is not a concern to us in wine grapes. Pruning. A lot of us are doing pre-pruning by machine. Some people are box hedging. For green season operations, a lot of the acreage is now mechanically assisted for leaf removal. Some people are doing shoot thinning for management. 100% of all our vineyards have been mechanically hedged or caned, because this is nothing new. And some people are doing crop load management, which is fruit removal by a machine, and this can be done by harvesters or by force balance strikers, as I will show. Here's the mechanical cultural practices and the trellis type adaptability. California sprawl, vertically shoot position, quadrilateral systems, single high wire, and head trained vineyards. So California sprawl, quad, and single high wire, these are all sprawling systems. VSPs shoot positioned, and head trained vines are the old school goblet type vines that are on vertical cordons. So pre-pruning, final pruning, shoot removal, leaf removal, berry cluster thinning, trunk suckering, and harvest. All of them can be mechanically harvested if they're on a trellis, if we can transfer force. But, sprawl, VSP, and a single high wire are the most adaptable ones to a mechanical harvest. As far as pre-pruning goes, quads, single high wire, VSP, and sprawl are quite adapted. final pruning, like precision mechanical pruning, single high wire is the most adapted. Shoot removal, again, single high wire is the most adapted. Leaf removal, both VSP and single high wires are more adapted. Berry thinning by machine, high wire is the most adapted. And trunk suckering can be done in all of them by machine, but taller trunks are going to lend themselves to mechanical management easier. So we have two systems that stand out for a high efficiency mechanical production in California. You'll see the single high wire system and the high quad at the Oakville station, if we don't float away. Single high wire system is 62 to 66 inches tall. It's a single plane canopy. It's not chute positioned. It has about 35% exposed leaf area, meaning that you still have 65% of the leaves inside the canopy. So unlike the previous work I showed you, this is a different arrangement of leaves. This can get into a production in 18 months if you're using Uber or tall vines, if you plant these in the dormant season. Our production ranged from 11 to 24 tons to the acre and 7 by 10 feet plant spacing density. High quad you'll also see at the Oakville station. This is a 68-inch tall canopy. It is a divided canopy. It can have a 36 to a 48-inch cross arm. It is non-shoot positioned. This is about 70% of exposed leaf area. This can also get into a production in 18 months if you're using dormant Uber or tall vines. Our yields in our experiments up and down California, we've seen 14 tons to the acre with red grapes like Cabernets, or up to 32 tons to the acre with muscat types, like muscat of Alexander types. But 32 tons to the acres, it might seem like a lot, but it's not a huge volume when you consider the amount of white grapes that are crushed in California. So you'll see these when we get out into the field. You'll see the dormant structure in them. Here's a single high wire. Single high wire, there's usually a stake at every plant to transfer the force from the harvester as you're picking these. It's a bilateral trained cordon. Of course, it's manually, attached to the cordon wire. The way this system works is here's the line stake. This is an engineered stake that's beveled to deflect the wind, so that this canopy doesn't act like a sail when we have winds. So you set up this cordon here. You will set your spurs in the first year, manually prune it. After which point you come through here with the box pruner that you will see at Oakville, and then give them a nice haircut at about 4 inches of bearing height, and then this generates a nice canopy that you can manipulate very easily with machine. High quads, you have as the name suggests, you have quadrilateral cordons. You have 1, 2, 3, 4 cordons that are spread about 24 inches at about 54 inches above the vineyard floor, and then you have this cross arm on top where you push the shoots through the catch wires in the top to let it sprawl. So it's like the UCD 60 on steroids, but this has been a very productive system that can be mechanized for us in Lodi and Sonoma regions. So as I mentioned, the desirable aspects of harvest, but I want to re-emphasize that in our economy, in our business, yield is paramount. Everybody talks a low yield game, but yield is what pays the bills. Do not discount this. We prune the grapevine. We prune the grapevine because of its fruiting characteristics. Fruiting shoots are born on 1-year-old dormant buds. Matthew Fidelowicz and Ashraf Al-Karimi talked about the dormant buds. Because of this trait, we prune to replace the fruiting wood in each year. Pruning results in a removal of 80 to 90% of the dormant canes, per year. You can do this by hand, or you can do this by machine. So this is the happiest picture of graduate students, pruning VSPs, because it's a fun time, I think, because they're getting closer to graduate once they get these data. We prune to remove the plants off the vine for horticultural objectives. It controls the size and the form of the grapevine. They're not growing in the nature anymore. They're an understory plant. It's not a long-lived plant. It likes to climb. We're, putting it in a, confined space, so we need to control the size and the form of this plant. It will optimize the potential of production of the grapevine, and the main goal is to balance between vegetative and fruiting growth in this case. So this machine is parked where I left it when the sun was shining. Hopefully we can move it this afternoon. But pruning has an effect on the grapevine. So these are some of the principles that you will get from the textbooks, and they do hold true. The plant will only ripen a certain amount of clusters in a given season. It has a capacity. Pruning has a depressing effect on the grapevine. Although the plants are dormant now, it's still alive. So if you chop off an arm, if I chop off my arm, it's going to depress me. So it has a depressing effect on the vine. The capacity of this plant is directly related to the number of shoots that you retain on the vine. And production of the crop will depress vine capacity as the years go on. The vigor of the shoot. Vigor, what I mean by vigor is the rate of shoot growth per week or per month, is indirectly related to the number of clusters that are on that shoot. Therefore, bud fruitfulness, the return bloom or return bud fruitfulness, is going to be indirectly related to the rate of shoot growth per week or per year. So Matthew Fidelowicz has a good paper in Catalyst, which I don't think is open source yet, that talks about the girth and length of these shoots. Older growth, larger canes and arms, meaning that a lot of storage compounds like starch, carbohydrates, etc., are able to carry more fruit versus newly established cordons. So, textbook stuff, let's get into reality. Types of equipment available to do pruning. We have pre-pruners and we have combination pruners on the market to do this mechanically. Pre-pruners, you have various manufacturers, various materials of construction. My recommendation is to avoid any kind of aluminum when you're buying vineyard equipment. Pre-pruners will usually do one plane of cut. These are mostly adapted to vertically shoot positioned type canopies. You have to follow these up with manual operations. Combo pruners, these are usually made in the U.S., not in California because of our tax structure. They do multiple planes of cuts. They may be also used for pre-pruning, if that's your secret sauce, as well as a finish and a precision pruner. They may be used in many types of canopies, including split canopies and California sprawl. Justin Morris did a lot of the preliminary work and discovery work with vineyard mechanization in Arkansas and also in a French camp in California. So this is his figure. You have to imagine or think about the continuum of pruning, the number of buds or percentage of nodes that you remove during pruning. You can remove up to 90% of the nodes or 20 to 10% of the nodes. 90% of nodes removal will be a severe pruning to attempt to simulate hand pruning. If you're removing only with a skirt cut or a top cut, light pruning, this is what would be referred to as a minimal pruning. Now, we had some nightmares both in New York and California with minimal pruning. Someone came and said, like, vines self-balance themselves. Of course they'll self-balance themselves. They'll starve themselves to death because they're trying to put on as many flowers. Grapevines will not mature or are able to keep 250 clusters on them. Minimal pruning is all but discarded in North America because of our production capacities. What we're mostly doing is severe pruning by machine. As you retain more nodes, or if you're removing less nodes from the system, you're decreasing pruning severity. You're also increasing the need for crop adjustment during the growing season and increasing disease pressure from the older parts of the grapevine. Dormant pruning by machines is nothing new. We've been doing it for about 30 years. There's a new and more advanced machinery. The secret sauce of the new machines is being able to do the undercut with the mechanical pruners. Dormant pruning is done during the dormant season, hopefully avoiding the incidence of rain. The severity of dormant pruning will define the bearing surface. This would be the bearing surface. And it will define the capacity. Larry Bettiga and I and the other farm advisors just published a new paper in Hort Technology, on the new costs, but the relative percentages of savings still hold true. This is from our 2012 paper. Spur pruning by hand is roughly costing us 30 cents a plant. Cane pruning with tying is costing us about 48 cents a plant. Mechanical pre-pruning with hand follow-up is costing us 36 cents a plant. Box pruning in a single high wire is costing us about 7 cents a plant. Operations labor cost. So you have some economies of scale. Not everybody is managing an 18-acre highly manicured vineyard in Tocolon. Majority of the people are dealing with square mile section vineyards. So 7 cents a vine is a tremendous savings. But mechanical pruners have to be set up, and as you'll see this afternoon, they're somewhat complex machines that look like they're from the movie Mad Max. You have to decide on a spur height. This will define the height of the bearing surface. Commonly, at 4 inches of spur height, you're doing a precision prune. 6 inches, this is a pre-pruning with a manual follow-up. 8 inches of shoot length, like Mondavia is doing at Tocolon, is a pre-pruning where you can bring in a piece rate crew from Kingsburg to finish up the pruning. You have to decide on the bearing surface girth. This sets the width and the depth of the bearing surface. Commonly in sprawling canopies, this is completely removed. The width of the box is usually set at 4 inches, but in Muscat of Alexandria types, Muscat of Alexandria type of grapes, I spent too much time in Fresno. I'm like repeating their mannerisms. They will leave them a little bit wider to get the amount of crop. You can drive these machines quite fast on T-tops or VSP canopies, 1 to 1.5 miles an hour, because we have too many rake or catch wires. Single high wires, we can go up to 2 miles an hour, but in the absence of reliable sensing, we have to measure and measure often. So here are parts of a mechanical pruner. This is a sprawling combo type pruner. So you have 2 rotary blades, 2 sets of rotary blades. The distance between these is what's going to set the bearing height. You have these sickle bar cutters. You have 1, 2, 3, 4 of them, and you have these skis in the bottom to get you guided into the row. And you have this shoe that's hydraulically assisted, and it's also got a Ferrous metal sensor. So when you hit a stake, If you have T-tops, it'll open this pruning head so you don't chop the tops of the row. But like I said, measure and measure often. So this is a T-top California sprawl canopy. This is a Cabernet Sauvignon Clone 8 on Freedom rootstock. It's my favorite combination. I hardly see it in Napa, but anyways. So here, you see the gentleman measuring the girth of this canopy, and then they will come through and adjust the sickle bar cutters to get rid of the sprawl that's has fallen under the cordon wire. Then they will adjust the rotary cutters. Now these rotary cutters, I've been working with mechanization equipment for some time, and I give similar talks probably in all continents. And most commonly, I see like saws. Instead of these rotary cutters that are self-sharpening, I see a lot of saws in European equipment. Our conditions are quite different in California. At the end of a half-mile row or a third of an acre row, whatever your situation might be, the saws have to be replaced. So, a management unit is usually about 80 acres. That's 259 rows. So you don't want to replace 259 saws just to do mechanical pruning. The moment that machine is not running, you're losing money. So we're recommending these, self-sharpening, rotary cutters, and most of the manufacturers adapted to this. Again, you have to set these sprawl cutters correctly as well to remove it, and then you have to adjust the height of this, cutters as well, so you don't drag this machine on the ground. So here we are doing the pre-pruning in this trial. So we were trying to compare pre-pruning with manual follow-up, or precision cut comparing costs. But in the end, the numbers were pretty clear that pre-pruning with a machine in major production areas did not pay for us. Shoot thinning is also done by a machine. Of course, dormant pruning is shoot thinning or shoot removal. You also do trunk suckering by a machine when the shoots are about 1 to 3 inches in length. What I'm talking about shoot thinning is when the shoots are about 8 to 12 inches in length to open up these canopies in the sprawling types as a means to control some of the overcropping. What shoot thinning does is it reduces shoot density, right? You're removing shoots. However, our light relations are so that in California that the more spaces you open on these cordons, the more laterals you're going to push out. So you have to, manage irrigation, very closely in these mechanically managed systems to avoid canopy repopulating again. It is an efficient method of crop thinning. It assists in the establishment of good positions for the next year. And of course, it'll reduce pruning costs in the next season. The cost per acre of shoot removal can cost $80 an acre if you're doing by a machine, or about $300 an acre if you're bringing in a crew. Shoot removal. This is the shoot removal head. Various manufacturers. Palenka manufactures one. VMEC manufactures one, and then Blue Line out of Washington has one now as well. The things to consider is to how many shoots per acre do you want to leave, or how many shoots per run of canopy do you want to leave. You have to be able to differentiate between count shoots and non-count shoots. I guess I'm not good enough to be a editor of American Journal of Enology on Viticulture, but my paper gets cited on what a count shoot is and what a non-count shoot is on a grapevine canopy. Count shoots are the ones that you would normally expect to burst from a position that you have left. The non-count positions are the ones that are bursting from parts older than 1 year, or from the latent buds. You have two parts to this. The cordon brush, follows the shoot thinner head. The shoot thinner head is here, and this will strike the canopy at a known revolutions per minute. And you set this up by how many shoots that you want to retain on this system. The cordon brush will, gently remove the shoots or the hangers that are on the underside of the canopy. You can add up to 12 paddles on this shoot thinning head. Tractor can go up to 1 to 1.2 miles an hour because this is a little bit of a more delicate operation. We can now do this with sensing. We can relate canopy relationship to satellite images. We just published this paper recently. If you do not have a GIS department in your company, these rows are half a mile long. Every 76 vine, you set up a grid, usually a 30 meter by 30 meter grid, in an 80 acre plot. You would need 11 points that are equidistant to get the initial shoot density of these vineyards. Now these are Pinot Gris plants, and they're notorious to fruit, but we did a lot of work with Pinot Gris. So this is the Pinot Gris setup. This is a setup for 11 shoots per foot of row to be shoot thinned in this vineyard. Essentially, you line it up and go through the vineyard, and you can check the efficiency of this system or the accuracy of this by sending people to your sentinel vines down the row to make sure that you're hitting your targets. Now, shoot thinning, as I mentioned, is a efficient method of crop thinning. It'll also open up the canopies. We did a lot of work with Syrah, although it has fallen out of favor. You cannot give away Syrah now if you tried, I guess. But we compared hand-pruned Syrah to box-pruned Syrah, 1, 2, 3 box-pruned treatments at 5 shoots, 7 shoots, or 15 shoots per foot of row. And these were all mechanically managed. As you retain more shoots per foot of row, you're going to reduce some of these berry masses in these sprawling systems. Cluster weight will also decline, but you have a lot of these smaller clusters. That's going to increase your yield in tons per acre. Now these are yield averages. I know it's funny to show this in Napa because the economic cutoff for this region was 12 tons to the acre. But if we match this to an RDI early stress treatment, where we stressed them between fruit set and veraison, we were able to hit 12 tons to the acre in this system, no problem, year after year. Your ability to make the same plant year after year is key in these mechanized systems. So if I irrigate them to a control treatment, what I'm calling here is what I'm call RDI control in this figure is a sustained deficit, where the plants got 70% of crop evapotranspiration replacement. As I left more crop here, I was devigorating the plants. This is a pruning weight per meter of row. In hot climates, warm climates, we're looking for about 0.9 kilogram of pruning weight per foot of row, or 0.7 pounds of pruning weight per foot of row. If I change my irrigation a little bit, I stress them to 50% of crop evapotranspiration between fruit set and veraison, but the rest of the season was 70% of crop evapotranspiration. I invigorated them, and this crop load mid-treatment was the sweet spot for red wine grape in Merced County. So this is 1 year. It's not the same figure. It's the second year. I'm able to make the same plants year after year. So irrigating these vines is key. Now, this shoot densities have an effect on berry chemistry. I'll just cut to the chase. A combination of crop load mid and this early RDI stress treatment gives us the highest anthocyanin content and highest tannin content in the San Joaquin Valley in the high production areas. Yesterday there was a question about red wine flavor indicators. So we published this paper just last year. We monitored methoxypyrazines and jammy flavors. I mean, you can monitor everything you want, but in the end, when you go across a consumer panel, these are the odor active compounds that the consumer panels recognize. Here's methoxypyrazines. Hand-pruned vines are producing 5 tons to the acre, irrigated with RDI control, sustained deficit, and hot climate has the most methoxypyrazines. If I change the irrigation to this with a little bit of stress, these are sprawling canopies. As the crop weighs down on them, the middle opens up, and you're able to expose, since methoxypyrazines are photolabile and thermally regulated, you're able to burn them up. But box-pruned canopies, they hardly produced any methoxypyrazines. 5 shoots per foot of row, 7 shoots per foot of row, 15 shoots per foot of row. Why do you think that is? When you hand prune, a bilateral cordon in Fresno to, international recommendation of 5 shoots per foot of row, you're opening up too many spaces. You have too many non-count shoots that burst that do not have any fruit on them. So you artificially create this 68-degree Fahrenheit temperature in the canopy where this fruit did not burn up the methoxypyrazines. Conversely, beta-damascenones did not have any, impediment to production. However, this hand-pruned grapevines, although they were producing beta-damascenone in the finished wine, the odor activity of beta-damascenone in this blue line was not enough to overcome this methoxypyrazine in the end. But so what I'm getting at is, this ideal balance at 7 shoots per foot of row with RDI early stress treatment gave us the highest yield, highest flavonoid content with the most pleasant wine aroma. Berry cluster thinning, 2 schools of thought. Like I said, you can do a pre-bloom thinning or a post-fruit set thinning. We see the most beneficial responses if this is applied when berries are BB size. Post-veraison applications, we see it constantly. They're mostly self-gratifying. We don't see any physiological benefit. So here's a manual cluster thinning. This is from a vineyard off of Route 29. It's an older vineyard, as you can see by the color of the wood. Usually people will place them and say we do not want the clusters touching each other. Clusters don't know what's touching them or whatever. So there are all these snake oil sales that are going on. But this is what a manual cluster thinning looks like. Mechanical fruit thinning is essentially a mechanical berry removal. If you know what you're doing, you can do this by a harvester. We had the best results when we set the harvester head speed at 200 RPMs, driving about 1.2 miles an hour a row, and then you'll pop off some berries. There's also implements available if you do not have a $400,000 behemoth. This is a force balance striker. You can push this into the canopy, and then it'll shake off the berries when they're about 3 to 5 millimeter in stage. We do a lot of cluster thinning work. The effect of cluster numbers on canopy variables and fruit composition. If you retain 1 cluster, 2 clusters, or greater than 2 clusters per shoot, you're not going to affect anything on the canopy. The distance between shoots will not change. Leaf layer numbers will not change. And this gamma is square centimeters of leaf area per length of shoot. This is a vegetativeness index. This will not change. What you might be able to manipulate is, you can, change the ripening speed a little bit, but unless you have like some virus issues, I do not know anyone that is unable to hit 23 bricks in California. Leaf removal is essentially half our acreage in California is done by a machine. You can do the leaf removal on both sides of the canopy. Usually we will remove leaves on the shade side of the canopy. This is a wonderful ranch that we're doing some work in Fresno Madero border. The cost can vary between $80 to $250 an acre, depending on if you're doing this by hand or by machine. Again, this will depend on the trellis type, the timing, and the density of the canopy. But it can be done by a machine very easily. Types of equipment available. I don't know why I was thrown into this in the earlier part of my career, so I evaluated these three types of machines. Initially, machines were suck and cut type of implements. They were very simple. It was just a giant vacuum with a grate on it. These were mostly adapted to vertically shoot-positioned trellises. There was a lot of damage to the flower cluster and the clusters, and these did not work at all in sprawling canopies. There's also air blast type of leaf removal implements. These are mostly adapted to vertically shoot-positioned trellises. They did not work as well, or I should say not at all, in sprawling type of canopies. However, they do not make a lot of damage to the flower cluster and to the infrutescens. But you need at least an 80-horse tractor to pull these, because you're filling these 6-foot air tanks to put these air blast into the canopy. What we liked the most was the rollover type of implements. They were adapted to all types of canopies, VSB, split, sprawling type of canopies. And these are selective. This is an older model. What they do is you push this into the canopy. As it rolls over, it'll just remove the leaves and leave the petioles. You can even do a pre-bloom leaf removal by machine with this type of implement. Leaf removal is self-explanatory. Here's an implement on a single row attachment. We even were able to do this in head-trained cane-pruned canopies. What you have is an 18-inch window here, and you can adjust this baffle. And on sprawling type of canopies, you have this sickle bar that will get rid of the sprawl, and as you push it into the canopy, you can open up this thing. Leaf removal is very effective in over-vigorous sites, especially in hot climate zones. And we can talk about the biochemistry till kingdom come, but I'll just show you some numbers per acre. All the vines were pruned the same. They either had a leaf removal, pre-bloom, or post-fruit set. This cost about $30 per hectare labor operations cost. We had 2 different irrigation applied, sustained deficit or regulated deficit. Of course, irrigation cost changes by the amount of water you would apply to the irrigation district. Here's the kicker. This is total skin anthocyanin production grams per hectare. So we're in the business of growing grapes and some flavonoid compounds. You can grow lots of shoots and leaves and sell Christmas wreaths that with Boy Scouts, I guess. So control vines irrigated to a sustained deficit. We were making about 1 kilo of anthocyanin per hectare. I just changed one practice. It can either be a regulated deficit or change it to a pre-bloom to a regulated deficit. I doubled the amount of anthocyanin produced per acre or hectare. So it's going from 1 kilo to almost 2 kilos. But what resonated with the growers in these warm climate regions was that the unit production cost per gram. So it was $1.56 a gram to produce anthocyanin, and this goes down to like 80 cents a gram. So, I mean, these are huge savings. So you're not just like growing shoots and leaves with like a little production of desired compounds into the berry biochemically. You're also, saving a lot of resources and labor. So this was consistent year after year, and this is a very good method to, move things on in the vineyard as, our production methods develop. But you have to relate this to production efficiency and how you measure efficiency. We have to relate this to the leaf area or to the vegetative growth, and this has to relate to fruit yield or reproductive growth. So both Larry and I showed this graph earlier, and we talked about this earlier in the ideal situation. We need to keep these within these guidelines between 5 to 10 for optimum regions. So I'll just, show this, putting this management into practice in the most difficult to mechanize system, Pinot Gris. This has to be managed by, crop load management, either Pinot Gris or White Zin. Irrigating these things correctly is the key. Here's Zinfandel 1A. This is irrigated by the grower. And this is irrigated Zin by us for a mechanically pruned system. You would think the yields in these are like not even going to compare. These did not make it to harvest. They petered out at 16 bricks because they all split. But irrigation trigger for us is negative 8 bars leaf water potential. And if we keep this at like negative 10 bars the whole season for White Zin or Pinot Gris, we're doing well. We recommend mechanical hedging for upright varieties, about 11 count shoots per foot of row, 4 to 4.5 leaf layers for white varieties. And here's the kicker. You have to, think about, what's going on in your pocket. Here's the threshold, 12 tons to the acre. Here's a crop load, pound of fruit, pound of pruning weight. If I draw the 5 to 10 lines here, I will be under the threshold. Okay? So for white grapes in warm climates, you can move this to 10 to 13. And in our wine tasting trials, crop load of 13 is when things start like tasting a little bit washed out. And there's a reason for that. Because we're trying to keep, 0.7 pounds of pruning weight per foot of row, and that also falls within 10 to 13 crop load ratio in these white grapes in the hot climate zones. I'll just show you one more economic table from one of our publications. This is average labor operations cost for canopy management in Pinot Gris. I don't know why we did this study. It was 12 treatments. It's hand pruned, mechanically hedged, different shoot densities, different leaf removals. Here's the canopy management cost, gross income per acre or hectare. We have 1, 2, 3 treatments that are in the black. So as we adopted these systems, we have to consider this mechanization to be the new reality or the new norm, and plants might not look as good, as attractive, but they do perform very well if you just follow the basic principles of whole plant physiology. So I'll end here because Lynn's going to need her full time.